Welcome back. We were seeing differences between structured and unstructured data, and we have seen four types of data analytics and why we opted with the NoSQL. So the reasons behind selection of NoSQL we have seen. And when we say NoSQL, it is nothing but no structured query language. Moving further, machine learning. What is machine learning? It is a scientific study of algorithms and statistical models that computer systems use to effectively perform a specific task without using explicit instructions, relying on patterns and inference instead. So machine learning is a part of computer science in which we have scientific methodological study of algorithms and we have statistical models. So that using those algorithms and models, we are going to view or visualize the data that we have collected in its easier terms. So relying on or based on the sensor data that we already have, so using the number of algorithms and available statistical models, we can process and visualize those sensor data. So that is the machine learning. It is a subset of artificial intelligence. Machine learning algorithms build a mathematical model based on sample data known as training data in order to make predictions or decisions without being explicitly programmed to perform the task. So in this case, based on the sample data available already, or based on the sample data which is collected from the sensors, we may train the data. The training in the sense we are making it easier to understand the data by our algorithm using a mathematical model. This is training data. So once we have this training data, it is easier for us to deal with the actual data so that we can apply actual phenomena for available data so that we'll get clear-cut visualization of the data. So when we say machine learning or deep learning or neural networks and convolution neural networks, so these are all come together along with the big data and IoT as well. Actually, machine learning itself, this entire machine learning itself is a main heart for IoT. So when we say IoT, as it is speedy, tiny, all those, the various factors is concerned with. So these are all very important part of IoT. When we have or when we can group machine learning as also part of artificial intelligence, under which we may have deep learning, neural networks, convolution neural networks, all those comes under artificial intelligence. Something like it may include different technologies that allows a computing system to interact with or to have an idea of intelligence in it. So nothing but saying that on the other hand, the algorithms should make use of or work as usual, as similar to the human intelligence. That's why artificial intelligence term came to picture. For example, we'll see an example. So we have a car, we have parked a car. However, we have a GPS sensor in that, which is reading the position of a car. And when you start moving, when your car starts to move, so automatically the GPS sensor will read the position. For example, whenever you shifting the gear from first gear to second to third, from 0 to 10 kilometer per hour, 10 to 30, 30 to 40, 40 to 60, and so on. So based on that particular speed, so now we can apply the intelligence, saying that if you move or if you drive your car in 60 miles per hour, then what will be the distance covered in an 1 hour? So this is the intelligence we are going to apply on that particular data. So data is collected in the form of speed, in the form of GPS location from one position to another position, as an example. So this is how we can apply artificial intelligence with respect to IoT as well. We'll see a little bit about our machine learning. So the evolution, ML, the terminology. In 1950, a Turing test has been achieved. So what it did in 1950, it determined if computer has intelligence, and statistical methods are discovered and refined. Also, research was conducted using simple algorithms. Simple algorithms have been made ready. In 1952, first learning program, that is on game checkers strategy, was to win. 1957, first neural network for computers. 1967, nearest neighbor algorithm was written for basic pattern recognition. Bayesian methods are introduced for probabilistic inference in machine learning. So this is the major growth in 1967, and almost around 10 years to identify the nearest neighbor, so that we can identify the pattern and can compare. So one of the Bayesian methods are introduced in that particular year to along with the probabilistic data. In 1979, visual guidance moving robot vehicle was developed with the camera module. In 1981, logic-based learning, something new. On the other hand, it is the ability for computers to analyze data. It is ability for computers to analyze data to create rule to delete the junk data. So something analytics has been applied on this. So in this case, intelligence has been applied, that is by rediscovering of backpropagation related with the machine learning research has been employed. In 1985, speech recognition, that is baby style words, pronouns. So these things are recorded and compared with the already recorded thing. So speech recognition came to picture in 1985. In 1990, a big leap or a big jump to our machine learning environment. So KDA to DDA, that is work on machine learning, shifts from knowledge driven approach to a data driven approach. From knowledge driven to data driven. So scientists began creating programs for computers to analyze large amounts of data and draw conclusions. In 2006, deep learning, images, text and video recognition has been employed. And 2017, from 2016 onwards, there is a huge hype surrounding artificial intelligence hitting new heights. This is with the greater extent. And coming to the major domains in ML, so these are the various domains where we can have machine learning. On the other side, we can have our sensors in these many areas, these many domains. Agriculture, we may have different sensors related to humidity, soil testing, all those kind of thing. Anatomy, adaptive websites, effective computing, bioinformatics, brain machine interfaces, computer networks, computer vision. So many. These are the different domains that we can apply. ML can have an ML, can have machine translation, marketing, medical diagnosis, NLP understanding, advertisement, optimization, so many. So these are the various areas where we can see or we can apply machine learning. On the other hand, we can apply IoT as well. in the various domains or areas. So now when we have this kind of facility with respect to machine learning, we are dividing the machine learning into two. One is supervised and unsupervised learning. Supervised learning is nothing but the machine is trained with input for which there is a known correct answer. So we know, so which is the exact output input that is to be given, and we can easily predict it on the other side. So on the other hand, the machine is knowing what will be the result. For example, you can see an example over here I've added. Training a system to recognize when there is a human in a mine tunnel. So the task is to equip a sensor with the basic camera. It can capture shapes and return them to a computing system responsible for determining whether the shape is a human or something else. It's a task. So now what is this supervised in this particular example is a camera has been set up, camera module has been set up. So its camera's job is to capture the shape and return and send back to the computing system or processing. So in the processing, we're supposed to write a program or algorithm so that the algorithm is to bifurcate whether that particular object or shape of the object, whether it is a vehicle or a pile of ore or a rock or wood or a human. So now for each individual, these bifurcations for a vehicle, all those things, we have some dimensions. Can set up those dimensions and we can compare. So with this number of images has been captured by the camera module. So using supervised learning techniques, we can label each image, whether it is human or non-human. That is training set. So bifurcation of clear-cut bifurcation of images, which is already captured, which is captured by the camera. That is, we are training the data. So now when we apply an algorithm of machine learning algorithm for this training data set, it is supervised learning. So that is an algorithm is used to determine common parameters and common differences between the images. That is how supervised learning works. So each new image is compared to the set of known good images. And a deviation is calculated to determine. That is deviation in the sense how it is different than the previous original message is or from the original human. Nothing but we are applying classification to classify after comparison with the images which is already available in our database. So once it is training is done, the machine should be able to recognize human shape. So because we already did the different trainings, we bifurcated based on the object, vehicle, rock, piece of wood, pile of ore. So all those bifurcation has been done. Nothing but labeling is done. So once we have that label, so whatever the images we got, we supposed to compare with that label. If it is matches, we may say it is a human or nothing but other object, saying classification. So once we have that, it is easier to recognize human shapes. That is as an example for supervised learning. Another as an example, speed of the flow of oil in a pipe is a function of the size of the pipe and viscosity of the oil, pressure, and few other factors. So now, to apply in this particular scenario, to calculate the speed of a flow of oil in a pipe, train the machine with the measured values. Train the machine with the measured values. The machine can predict the speed of flow for a new and unmeasured viscosity. This is called regression. So what is its job? Regression's job is to predict numeric values. So over here, speed of the based on the pipe diameter and speed at which the flow and the pressure. Based on that, we can calculate the oil which is flown from one side to other side. So this is the actual job. So this particular setup is nothing but regression. because we're supposed to predict numeric values, number of liters, number of barrel, or based on our need, we can categorize it. On the other hand, the classification is nothing but bifurcating based on the label and images. So that is supervised learning. Coming to unsupervised learning, it is undetected pattern in a data set with no pre-existing label. So unsupervised in the sense, we cannot have a label. We don't have enough material to bifurcate each and every pattern. So there is no pre-existing label as well. So its algorithm's job is to learn the environment and trace out whether there is an intervention in between. On the other hand, we can say there is very less human supervision. Everything is monitored via the algorithms. Consider a situation. Here is an example. Consider a factory manufacturing small engines. So with respect to this manufacturing unit, we may have a factor 0.1% of the produced 0.1% of the produced engines on average need adjustments to prevent later defects, and task is to identify them before they get mounted. What to do with this? So there is a manufacturing industry manufactures small engines. So on an average 0.1% of the produced engines may need some adjustments. So how to do? So need to test each engine and record multiple parameters as sound, pressure, temperature of key parts, etc. Once this data is ready, then we can have a graph. Can graph these elements in relation to one another. Can compare with the other. For example, when we say engine, is supposed to check it out the sound, check out the pressure, check out the strength of each hardware device in that, check out the temperature of a key part, check out the activity of uh, communication, pressure mounted, all those factors. Supposed to record individual, all these parameters should be kept recorded separately, so that we can have those data, can input those data into a computer and use mathematical functions to find groups, so that we can decide to group the engines by the sound they make at a given temperature. So for this reason, we need to apply some standard functions. Methodology has been employed. For example, k-mean clustering. So k means clustering. On the other hand, we are grouping. Clustering is nothing but grouping based on one particular criteria. So k-means clustering finds the mean values for a group of engines. For example, mean value for temperature, mean frequency for sound, mean pressures. So based on that mean or average, can group the engines. The way can quickly reveal several types of engines that all belong to the same category. All engines of the same type produce sounds and temperature in the same range as the other members of the same group. So now we are going to bifurcate by analyzing different parameters like sound, pressure, temperature of everything. So based on this, we have two categories. On the other way, clusters. So one is based on the temperature, other one based on sound. It's supposed to group all those engines. So once we have grouped all those things, then we can easily put it on a graph saying that we can easily bifurcate. That is unsupervised learning. Moving further, we have neural networks. Neural networks is again a part of artificial intelligence. So it will process multiple dimensions, which requires a lot of computing power. It is also difficult to determine what parameters to input and what combined variations should raise red flags. So nothing but using machine learning methodology, machine learning algorithms, we are trying to have a human brain kind of working using our algorithms, that is neural network. For example, when you look at a human figure, multiple zones of your brain are activated to recognize colors, movement, facial expression, body language, eye contact, all those. So brain combines these elements to conclude that the shape you are seeing is human. This is how the brain works. Similarly, to develop such an environment in the algorithm, we go with a part of machine learning, that is neural networks. The information goes through different algorithms. So we'll call it as units, each of which is an charge of processing an aspect of the information. So we'll divide the algorithms into different units. We'll give each units for an individual job to process the information. Then we are going to club all those outputs or results for easier computation. So this computation value can be used directly or fed into another unit for further processing to occur. So here is an example how neural networks recognize a dog in a photo. Please follow my cursor together. Suppose to have a training set. During the training phase, a neural network is fed thousands of labeled images of various animals, learning elements, learning to classify them. This is a setup, training data. So during training, we supposed to have number of images so that it can easily bifurcate various animals. So labeling has been done. So once we done with the labeling, it is easier for us to bifurcate with different animals. So classification has been done using those labeling. That is training. So once it is done, then we supposed to input the data. Though this stage input is nothing but it is unlabeled image. So whatever we can see through the camera, that has been input. Then once this image, unlabeled image is ready, we have fed into the network. So with respect to the first layer, the neurons respond to different simple shape like edges. So first layer in neural network will go with the edges or edge detection with the object, whatever the object we have fed, that is in the form of an image. So in the first layer, we have a set up some neurons will respond to the different shapes. So these shapes already decided via training. Then in the higher layer, neurons respond to more complex structures. Complex structures, for example, eye, nose, tail, body of a dog, all those comes into in-depth, that is in the form of individual units. That is in, and then in the top layer, so neurons respond to highly complex, abstract concepts that we would identify as different animals. For example, barking, noise that they make, dogs make noise made by other animals. So these are all the comes under in-depth top layer employments. So need to compare with all these criteria. First layer, higher layer, and top layer criteria, neural networks criteria. Then we are going to compare it with the training. The network predicts what the object most likely is based on its training, whether it is a wolf or a dog. So that is how this neural networks works. So initially we'll start with the training. We'll feed thousands of images of various animals. We'll note down all those categories, characteristics of individual animals. Then once it is ready, then we are going to input an image of an animal. In the first layer, it will respond to the shape and its edges, all those things. Higher layer, neurons respond to more complex structures of that object, of the shape of the animal. Then in-depth employments of neurons, which have abstract concepts as to bifurcate different animals. Then we are going to compare output of this one with the training value. So then we'll get an output stage. That is whether it is a dog or other animal. So that is how neural network works. So any clarification so far? If you have any doubts, please get back to me. We'll take a break and we'll come back.